Hello, everyone. Welcome back to our weekly discussion. Today will be a project pitch extending the Q-Learning survey, and the goal is to go from existing draft to publishable research. And we are not starting from zero. We already have a pretty mature draft, and it consists of Q-Learning and Deep Q-Learning taxonomy, Atari benchmark collection, classics control experiments, open source IL repository comparisons, and also a per paper literature review. And the goal is to polish, extend, and strengthen. And currently, we have a team size of 8 with people around the world and many cities such as New York, Taipei, and Waterloo. And it consists of 5 engineers, 2 PhD researchers, plus myself, project lead coordinator, and we are doing engineering plus research plus writing. And the paper title was Understanding Q-Learning and Deep Q-Learning in 2025, a methodological and empirical survey. And the core idea is to organize the evolution of Q-Learning. Why this paper matters? Q-Learning is a very foundational algorithm, but the evolution is pretty scattered. And our survey aims to provide a bunch of things such as a unified taxonomy, benchmark comparisons, implementation analysis for popular IL repository, and practical guidance for researchers and engineers. Our main contributions consist of unified taxonomy of Q-learning variants, literature review across 3 decades from 1990s to 2020s, and also Atari benchmark result collection from all the original papers, classic control experiments on these environments such as OpenAI Gym, and also comparison of major open source IL repositories such as Tianshou and Xuance. And we have decided on 6 main categories. Basically, we organize Q-learning into them, such as statistical methods, Q-function computation innovations, memory and replay innovations, ensemble-based Q-learning, model-based methods, and finally, pure Q-learning or minimal extensions. And the first category is statistical methods. The focus in this category is exploration, uncertainty, as well as treating Q value as a distribution instead of a value. And example algorithms including NoisyNet, C51, quantile regression DQN, implicit quantile networks, and fully quantile functions. And our second category consists of Q function computation. And here we are focusing on improving Q value estimation, reducing overestimation bias, as well as changing neural network architectures. And examples we have double Q-learning, the original Q-learning, double DQN, and also dueling DQN. And in the third category, we are talking about memory and replay, and here we are doing things on experience replay, sample efficiency, data reuse, as well as demonstration learning. And the algorithm here we have such as DQN replay buffer, prioritize experience replay, deep Q learning from demonstrations, and memory efficient DQN. And in the fourth category, we are focusing on ensemble-based Q learning and focus on multiple Q functions, uncertainty estimation, deep exploration, as well as robustness. And here we have the examples of bootstrap DQN, ensemble bootstrapped Q learning, as well as UCB exploration via Q ensembles. And in category 5, we are talking about model-based methods. And here, the focus is on planning, environment models, Bayesian reasoning, as well as sample efficiency learning. And here the examples include value iteration, policy iteration, and Bayesian Q-learning, as well as expected size. Finally, in the sixth category, we are talking about minimal Q-learning, and the focus is on methods close to original Q-learning, lightweight extensions, and clean baselines. And why does this matter? Because single baselines are still quite important in the modern landscape. Another contribution, we are doing repository analysis. And this draft compares major IL repositories such as Tianshou, 全测, clean RL, DQ and ZOO, stable baseline 3, as well as RL lib. And this will make the paper useful for both researchers and engineers. And the empirical component includes two of them. One, Atari benchmark result, which we extract from the original papers and all the original numbers, and we do not do any modification. Classic control benchmark, we will basically implement them based on the original papers. And so this survey will consist of literature, experiments, and code reality. And let's look at concrete feedbacks from the IEEE Transaction on AI journal. And the reviewers believe the paper is strong organizationally, it is technically broad, and it's useful as a descriptive survey. But they want deeper analysis, stronger synthesis, and clearer unifying insights. And first feedback, the concern is algorithms are presented one by one without enough high-level synthesis, and we will improve on stronger cross-method comparisons, identify shared design principles, explain trade-offs between methods, and try to unify algorithm families conceptually. The second feedback need more conceptual insight. Our current structure is like method A, method B, method C in each category, and the design structure may be why did this direction emerge? What weakness does it solve? What trade-off does it introduce? And which methods are philosophically related? And third feedback, Atari is not enough. The concern is that Atari and classic control are historically important but limited, and we need to discuss benchmark limitations, reproducibility issues, comparability across different papers, benchmark-specific improvements, and real-world generalization challenges. And the fourth feedback involves too much duration, and the concern is some algorithm derivations are too detailed for a survey paper, and so the suggested improvement can be involve reduce mathematical repetition, shorten low-level derivations, allocate more space to interpretation of the methods, and improve readability and flow. And it's like less proofing and more explanations. And finally, reviewer suggestions have demonstrated that distributed reinforcement learning, offline reinforcement learning, multi-agent coordination, meta-learning integration, and recent theoretical advances. And this may be many bigger opportunities for expansion of the original draft. And our concrete team tasks include the following, such as strengthen comparative analysis, improve conceptual organization, verify benchmark interpretation, identify modern RL additions, reduce redundant derivations, improve figures and tables, strengthen future direction section, and so on. And the final goal, the paper already has strong coverage, broad taxonomy, extensive references, and we need stronger insight, clearer synthesis, and deeper interpretations. That's the end of the discussion.